This video is intended to help you with Apex Section 5.1 exponents, and there's also some radicals in it. If at any point you're not being able to write down everything as I go along, just simply pause the video, copy down what you need, and then resume the video. Alright, so to begin, an exponent means repeated multiplication. Here I have an exponential expression, b to the a. That is an expression that has an exponent, hence exponential expression. This whole exponential expression, b to the a, can be thought of as a power. The whole thing is considered a power. And in the power, the bottom is the base. The superscripted number up top is the exponent. And the way this exponential expression works, the exponent tells us how many times we're going to multiply the base together. Now let's look at a couple examples here. I want to rewrite these as exponential form and then find out what their value is. So 5 times 5 times 5 would have a base of 5 because we're multiplying 5 3 times. Hence, this becomes 5 cubed. It is 5 multiplied together 3 times. Now 5 cubed, 5 times 5 times 5, would be 125. 5 times 5 is 25, and then 25 times 5 is 125. So we put the value as 125. Now I'm taking 2 times 2 times 2 times 2 times 2. Try this one. What would that become? Its base is 2, and we're multiplying it together 5 times. This becomes 2 to the 5th power. Multiply it out, and you should get 32. Now the next one's pretty quick. It's just 4 times 4. The base is 4, and we're multiplying it together twice. This becomes 4 squared. 4 squared is 16. Now this next section, we're going to look at how to do the zero and negative exponents. And I've got this table that's going to help me to figure out how to do these again. Now you may not remember how to do 2 to the negative 4th power, or possibly even 2 to the 0. But we should be able to go down below, and let's start with 2 to the 1st power. 2 to the 1st power just means a 2 multiplied once. That'd have to be 2. 2 squared, 2 times 2 is 4. 2 to the 3rd, 2 times 2 times 2 is 4 times 2 is 8. And then 2 to the 4th power would be that 8 multiplied by another 2, which is 16. Each time I did this, I took the 2 and then multiplied by another 2 to get the next term. Now what if I wanted to go the other way? Instead of multiplying by 2, I'd have to divide by 2, or better yet, let's just say multiply by half. It's going to make more sense for what we're doing here. So half of 2 would become 1. 2 to the 0 power is 1. To find 2 to the negative 1, we'll take 1 and multiply by half again. Half of 1 is half. 2 to the negative 2 becomes half of a half, which is a fourth, and so on. Now look for a pattern as I start filling in the other ones. Do you see a pattern to the negative exponents? Let's discuss it. Well, let's start with the zeroth exponent. What was 2 to the 0 equal to? Look at the table again. 2 to the 0 is equal to 1. And this is going to help me to derive my rules for the zero exponent. B to the 0, that is any base with the exception of 0. You cannot do 0 to the 0, that's undefined. Any base with the exception of 0 raised to the 0 is going to be 1. Now what do you notice about the negative exponents? What do you notice about 2 to the negative 1, or 2 to the negative 2, or 2 to the negative 3? Well, 2 to the negative 1 is really just the reciprocal of 2 to the positive 1. And 2 to the negative 2 is the reciprocal of 2 to the positive 2. This means those negative exponents are really just the reciprocals, that is, the fraction flipped, of the positive exponent. And this is how I'm going to define the negative exponents. If 2 to the negative 2 is really 1 over 2 squared, and 2 to the negative 3 is really 1 over 2 to the 3rd, and 2 to the negative 4th is really 1 over 2 to the 4th, then b to the negative n, again where base is not 0, is going to become 1 over b to the positive n. You take the reciprocal and make it a positive exponent. So let's try a couple examples. If I want to take 5 to the negative 3, it becomes 1 over 5 to the positive 3. Try the example number 2 now. What would 11 to the negative 4 become? Hopefully you're thinking 1 over 11 to the positive 4th power. Again, if I'm going too fast for you to copy down, just pause the video, copy what you need, and then resume the video. Now we're going to look at our exponent properties. Some books, and I think Apex even refers to these as laws, and you'll see it termed both ways, either exponent properties or exponent laws. So the product property of exponents is when you are multiplying, that is a product, 2 powers. If, for instance, I take b to the a and multiply it by b to the c, I need to figure out what that is equivalent to. Now b to the a means a many b's multiplied together. And b to the c means c many b's multiplied together. Together I have both a and c many b's multiplied together. Together means adding, so this is really just b to the a plus c. It'll make a little bit more sense when I talk about the next example. Here I've got 3 to the 7th times 3 to the 5th. 3 to the 7th means 3 multiplied 7 times. 3 times 3 times 3 times 3 times 3 times 3, 7 times. And 3 to the 5th means 3 multiplied 5 more times. Together I'm multiplying it 7 and 5 more times. That becomes 3 to the 7 plus 5, or 3 to the 12th power. Try example 2. What is 2 to the 5th times 2 to the negative 3rd? We've got 5 and an exponent of negative 3, both being raised for a base of 2, so I can say it's 2 to the 5th plus negative 3. 5 plus negative 3 is going to be 2, and this just becomes 2 squared, or 4. Now, a lot of times I'm not going to multiply my exponents out in Apex because it doesn't ask me to. Now, if I look at it and I don't see anything with an exponent, it's possible that they multiplied it out, and you may have to actually figure out, in this case, what 2 squared is. Certainly, they're not going to ask us what 3 to the 12th is in Apex. All right, now let's go to the power property of exponents. I want to take the quantity b to the a and raise it to the cth power. To do this, it means that I'm going to take b to the a times b to the a times b to the a c many times. And that's going to become b to the a times c. So let's try this with a couple examples. If I'm taking 2 to the 5th and multiplying by another 2 to the 5th and multiplying by another 2 to the 5th, that's going to be a 2 to the 5th plus 5 plus 5. That's going to be 3 groups of those 5s. So to do this, an easier way to do it is just going to be to multiply. This becomes, multiply your exponents, 2 to the 5 times 3, or 2 to the 15th power. All right, try example 2 now. We're going to multiply our exponents. 3 to 4 times negative 2 becomes 3 to the negative 8. Now, hopefully you remembered we don't leave a negative exponent. If you see a negative exponent, you want to rewrite it, and this is going to become 1 over 3 to the positive 8. Again, anytime we have a negative exponent, we don't consider it in simplest form, we rewrite it. We take the reciprocal and we make it a positive exponent. Now, sometimes you're going to see a product being raised to a power. Here I have the quantity a times b raised to the c power. I can think of this as just a to the c times b to the c. Both of those are going to be raised to the c power. Now this works for multiplication inside the parentheses, but not addition or subtraction. Don't try it when it's addition or subtraction. Let's try the example. The quantity 7 times 4 raised to the 3rd power. We can split it and say it's really 7 to the 3rd times 4 to the 3rd. Now we could also use order of operations and clean the parentheses up and say that 7 times 4 is 28 and just say it's 28 to the 3rd power. But that's going to be a lot harder to multiply out. Okay, let's look at some more properties. Let's go to the quotient property. Quotient is division, and here I'm dividing powers. If I take b to the a divided by b to the c, and again they have to be the same base just like the other rules we looked at, I'm going to subtract the exponents. This becomes b to the a minus c. In our example, 3 to the 7th over 3 to the 5th, this would become 3 raised to the 7 minus 5, or 3 squared. Now try example number 2. What do you think this would become? Well, I'm going to subtract my exponents, and it becomes 4 raised to the 2 minus 7. 2 minus 7 is negative 5, and I get 4 to the negative 5th power. But again, we don't leave a negative exponent. It's not considered in simplest form, so we'll rewrite it. It becomes 1 over 4 to the 5th power. Now, you also could have just looked at it and said, well, let's see, 2 and 7, the greater exponent's in the denominator on the bottom, which means when I subtract these out, there's going to be more of the 4's left in the bottom. 7 minus 2 is 5, and I could have just said it's 1 over 4 to the 5th, straight out. Okay, now let's look at some fractional exponents. And the fractional exponents are going to lead us to our radicals. So here I've got the base raised to the power of 1 over a. If you're raising to a fractional exponent, and whatever the denominator of the exponent is, that's going to become the root that you're taking. So if we do b raised to the 1 over a, this becomes really the a root of b. Or written the other way, if we're starting with the root, if we're saying the a root of b, we can say this is b raised to the 1 over a, excuse me. Again, the fractional exponent, if you look at the exponent, the denominator, the bottom of the fraction for the exponent, becomes what root we're taking when we make it into a radical. So let's try some of these. I'm going to take 16 and raise it to the 1/2 power. A 1/2 power would be taking the second root of 16. And the second root is more commonly called the square root. We're going to take the square root of 16. Now you may know what the square root of 16 is, and hopefully you do. But let's look at how we can solve this a little bit more strategically so we can start doing other roots. To be able to figure out what the square root of 16 is, I need to rewrite 16 as something squared. If I'm taking the square root, I want to raise my argument inside my radical to the second power so that the root and the second power are going to cancel. Now I know that 16 is also 4 squared, so I can say this is the square root of 4 squared. Here, the square and the square root are going to cancel because they're inverse operations, and it's going to leave me just the 4. The square root of 16 is 4. Notice there's no more radical. Now again, you may have noticed, it may seem like I'm going through a little bit more work than would be needed, but it's going to help us with some of the other roots. So let's look at 8 raised to the 1/3 power. 8 raised to the 1/3 power, the denominator of the exponent is 3, which means it's the same as taking the third root of 8. To evaluate this, I need to be able to think what 8 is as something as 2 raised to the 3rd power. So if I think of something raised to the 3rd power, and I know 2 to the 3rd power, 2 times 2 times 2, is what makes 8. So here I have the cube root of 2 cubed. The cube and the cube root, just like the square and the square root in the previous example, are going to cancel out because they're inverse operations, and this is going to leave me just the 2. Now if in a radical you have a product, you can split it. So the square root of a times b can be split and said it's really just the square root of a times the square root of b. And sometimes this is handy to be able to evaluate these a little bit easier. It's easier to take the square root of 9 times the square root of 100 than it is maybe to take the square root of 900. Because the square root of 9 is 3, and the square root of 100 is 10. 3 times 10 is 30. I can do this in my head easier. Now the next thing we're going to look at are our exponential expressions with fractional bases. So instead of the exponents being the fractions, now the bases are fractions. So if you have the quantity a over b raised to the x, this can be thought of as broken up, and it's just a to the x over b to the x. So try these two examples. Pause the video. All right, hopefully you had a chance to work it. This is going to become the quantity 3/5 squared can be written as the quantity 3 squared over 5 squared. 3 squared is 9, over 5 squared is 25, and it becomes 9/25. The quantity 4/3 cubed becomes 4 cubed over 3 cubed. 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. This becomes 64/27. Now with the square roots, I can do the same thing. I can split the square root of a over b when it's all inside the radical as the square root of a over the square root of b. So if I'm taking the square root of 4/49, I can split it and say it's really just the square root of 4 over the square root of 49. Here the square root of 4 is 2 and the square root of 49 is 7ths. So the square root of the quantity 4/49 simply becomes 2/7. Now if you see it written like number 4 here, keep in mind the fractional exponent is nothing more than a square root, in this case because it is the denominator of the fractional exponent of a base 2. So if it's a 1/2 power, that's the same as taking a square root. So the square root of 936 can be broken up as the square root of 9 over the square root of 36. The square root of 9 is 3, the square root of 36 is 6, this becomes 3/6. Now this time I can actually simplify it because 3/6 is going to become 1/2. Alright, thank you for watching, and hopefully this helps you to get through the assignment. You're ready to now take the quiz after you've looked at the lesson.